The goal of this evening is really just to do a kind of data display tutorial or workshop, I suppose. To do this, I'm going to basically be using we'll see about that, Orla. But so I'm basically using Excel to show you how you can actually work with data and how you can present it in a sensible way and how you can create very professional sort of publication-ready type material. So just as a quick refresher, have you all done graphs in Excel before? So do we take that as a no, folks? So the question, basically, I was wondering whether or not people have drawn graphs in Excel. And the follow-on part from that is whether or not you were happy with graphs in Excel. So we'll kind of run through it from the basics and go on from there. So for those of you not familiar with Excel, can everybody see this okay? Just to make sure everybody is able to see all the text. For those of you not familiar, it's basically a database program that has a spreadsheet interface, and it allows you to do calculations, and it allows you to do a variety of other different things. Okay. One of those things is charts or graphs. So what I'll do is I'll just take a couple of these. I mean, I'll show you, this is a big data set with gaps in it. You can see there's several gaps, but you've 200 odd rows in this. So it's a lot of data. So we might just work with a smaller amount just to kind of get started with it, okay? So I'm going to just select a small amount of data, and we'll use that as our starting point. So this is raw data, and it looks very messy, obviously. And I don't need all these crazy amount of decimal places, so for your own sanity, it's generally good practice to reduce them to something sensible. You're not eliminating them. What you're doing is just reducing the number of significant figures in Excel. And you'll see in the number window up here, you have a little option to decrease or increase a decimal. So we'll just decrease them until maybe we have 2. And then we can center them again. Now you'll notice that if I click on this cell, which is B3, so it's column B, row 3. It gives a very long, I think it's what, 12 decimal places? 14 decimal places for that, for all of the numbers. So that's not vanished. We still have all of that data. It's just, it's abbreviating it so it's more sensible to look at. So we'll go through the kind of basics of this. So what's one of, we talked about descriptive statistics before, so what are our key descriptive statistics that we would apply to a data set like this? Anyone? So what type of statistics would we use to summarize this information? We have 3 separate measurements on a bunch of different patients. So how could we summarize the overall material that we've got? Averages, yeah, Aisling. So the classic one is average. Okay, so typically the layout that I've used, where we have the actual analytes labeled at the top of the column, and then we can put in our summary statistics at the bottom, that's a fairly standard approach to take. If you're using a more sophisticated piece of software like SPSS or SAS, then it doesn't allow you to do this sort of thing. What it'll do is it'll effectively run a report on your data. But I think this is actually, in some ways, it's an easier way to get into the whole idea of using a spreadsheet to manage your data. Any other descriptive stats that you might want to use? Yeah, we might want the median. We might want the standard deviation. Anything else? Variance, yeah, which is the square of the standard deviation. And then we could even have the standard error of the mean. Okay? And the standard error of the mean is basically your standard deviation normalized to your sample. Okay. Yeah, we could have range. We could have confidence interval. So let's put in those. Range. Let's just call it CI. We'll call it 95% CI. Okay. I think we've got a lot of those to be playing with. And yeah, we could even do CV if it was method validation or method that we were interested in finding more details on. So let's just run through these now. I'm going to zoom in a bit just so you can all see what I'm doing with the formulas. Actually, what I'll do is I'll show you something that you'll find useful for dealing with large amounts of data. If you go into View, you get lots and lots of different options. And one of the ones that I would recommend you get familiar with and comfortable with is this idea of split. This will be very useful. So I'll just click on a cell randomly in the middle of the screen and I hit split. And now you see this gray crosshairs. So I can drag that up to the top and I can drag it along to the side. And now what I actually have is a way of moving through the data. Now you see it's showing me A twice. But effectively what I have, I've pinned the glucose, triglycerides, and cholesterol in one place. And I can move the rest of my data. And now I can use the option to freeze panes. Okay, so I've split the screen and now I can freeze the panes. And now what I have is a completely frozen situation where if I have lots of data, like my 200 odd samples, I can still see what the heading of the column is every time. Okay, and I'm just doing this so that we can all see it easily. So, how familiar are we with formulas in Excel? Have you used a lot of formulas? No formulas? Some formulas? Okay, that's fine. So, what I'll do is I'll show you two ways of putting them in. What I tend to do is I actually write in what I want it to do because most of the formulas that I use I'm very familiar with. So I'll show you the two different ways. So here's one of them. What I want to do is I want to have a mathematical function now to calculate the average. I don't want to have to do it longhand. So basically what you need to do is, where have we gone? Formulas. So you insert function, okay? And you see it has a list of different types of functions that it's got. We're interested in statistics. But if I click Insert Function, I get this window. And I can type in the formula I want. So I want average. And it gives me all of these different types of averages. And I just want the bog standard average at the top. Okay? Because it's a database type program, it allows you to do all sorts of interesting things like only average the males or only average the females, only average the numbers between 6 and 10, whatever it is. But we just want a standard average. So now when I click OK, it's looking for the ranges for what do you want the average of, ultimately. Okay? Now it'll try and be clever and guess what you want. And in this case, it's actually correct. So if I click the little symbol next to the white box here that I'm pointing the arrow at, that allows me to select data. And if I'm just going to eliminate that completely. And if you look up above in the sort of white box, I'll just move this so you can see it. So you can see that as I select this list of data, it's automatically selecting the average. It's showing me the formula above. So I want to go down as far as 20. So it's average B3 to B22. So Excel was smart enough to spot that for me. And now I'm going to hit OK. And there we go. I have my average of that data set. The other way to do it, when you're more familiar with it, is literally just to type it in. So I know the formula for average is average, and Excel is trying to be clever and present me with what it wants, or what it has available, so average. So that's the function. I open a bracket, and then I can pick the numbers that I want. So again, I'm scrolling up. Now you'll see it doesn't matter which direction I scroll in, whether it's down, up, sideways, whatever. As long as I have a continuous series of data, this will work fine. And then I close the brackets and press return, and I get my average. And if you're feeling particularly lazy, you can use this little black square. I'm sure you're all familiar with this. This little black square at the bottom of the cell in Excel, I can drag it across. Okay? So if I drag it across, what it will do is copy the formula to the next column. It won't copy the results, and you'll see this when I leave go. I have 3.77, and if you look at this blue square, that's showing you the data that is being used to calculate this 3.77. So the average is actually being calculated just by dragging it across. And that's the approach we'll take for the rest of this series of data. We'll work out everything for the first column, and then we'll literally just pull it across for the rest of them. So are we all happy enough with that, guys? I know it's very basic, but it's no harm just to go through it again, just to remind everyone what we're doing. Okay, so unsurprisingly, the formula for median is the same. Well, it's not the same as average, but it's the same as the name median. So if I put in equals, median, and then again, I'm highlighting my data. So close the brackets, and I get my median. Now, quick and dirty approach, if your median and your mean or average are about the same, that's a fairly decent rule of thumb indication that your data is normally distributed. It is not perfect. It is a sort of a heuristic rule of thumb. So one of the other ones that was mentioned was just standard deviation and variance. Now, standard deviation is a measure of the variance of your data, and it's actually the square root of the variance. So we can actually estimate the variance using the formula VAR. And again, scrolling up for our full data set. And there we have a variance at lots of decimal places. We'll tidy up all those decimals in a minute, but let's just leave them for the moment. And the formula for standard deviation is STDEV. Again, not very surprisingly, it's what you'd expect. Open the brackets, pick the numbers you want, and then hit return. Okay? Right, so the next one that we have that people mention is standard error of the mean. There is no built-in formula in Excel for this, so you actually have to write it yourself. It is not very difficult to do so. Okay? So, the first thing you do when you're composing a formula is put in equals, and I'll tell you what, I'm just going to put in the formula for standard error over here. It's standard deviation divided by the square root of the number of samples that you've got. Okay? Now, do people know how to use Excel to actually count the number of samples you have? Now, here we have 20, so it's pretty easy. But if you remember this big, huge data set, I have loads and loads and loads, but I have gaps in them. So anybody know how to actually count that automatically using a formula so you don't have to go through all of the pain of doing it yourself? It's a variant of count, Orla. Not exactly count, but it's a variant of count. But you're on the right track. There's a variety of different counting functions in Excel. So let's stick in a row for the number that we have. Okay, so count. So if we start typing in count, you'll see there's a bunch of different ones. Okay. Now, Orla, you said just count. That's counting contain numbers. Not the only, but a difficulty with that is that the format of the cells has to be numbers. One of the sort of, I suppose, easier way, well, not easier, but if you have a 0, it's going to get counted as a sample. Okay? So you can set it to count the cells that have an entry in them. So count A, open the bracket, scroll up, close bracket, and there you go, you have 20. And obviously it gives you decimal places because, well, that's the way it works. Now the reason we're doing it, I'm going to dump those decimal places because we don't need them for counting. The reason we're doing that is because if we have a large data set like the one I showed you, so if we put in count, okay, we have a very, very large number. I don't want to have to manually go in and count all of these, okay? I want the program to do the hard work for me. And there we go, 232. And just to show you that these are not all equal, 234 and 234. So we have missing data in some of these. But it doesn't matter if we're missing data, we can still use it. So now let's get back to a standard error. So it's based on two things. It's based on the count and it's based on the standard deviation, both of which we've calculated. So if we put in equals, we pick the result for standard deviation. And there's a good reason for this, and I'll show you in a second. And then we divide it by the square root of 20. You don't get out your calculator and calculate it. You type in SQRT, and that's the formula for square root. You open a bracket, and then you pick your count. And then you close the bracket. So now we've constructed a formula. B26 divided by the square root of B23. And I hit return, and that gets solved for me. Now, you might wonder, well, why did I bother putting it in that way? Why not just put in square root of 20? Okay, I'll show you why, for a very simple reason. Okay, and I'll just call this one SEM20. Okay, standard deviation divided by square root 20. Okay, so they're the same number at the moment, exactly the same. But because the top one, the SEM, I'll color code it yellow, so we all know what we're talking about. So because the yellow one is tied into the rest of the data, then if anything happens to this data, so if I delete 5 of the samples, it automatically recomputes. The count is reduced, the standard deviation changes, and the standard error changes. So it's all tied in together. Okay? So it's much better if you can actually have and construct your data tables in such a way that everything is linked together. I'll just get rid of this SEM21. And it also means that you can accommodate different numbers of samples. So if I'm just going to randomly delete a couple of these. So now we'll have different sample numbers, but that can be accommodated directly. Now, so they're the kind of basic things that we've got, okay? So if we wanted to calculate the range, what we really need to do is a couple of things. We don't just calculate it as itself, okay? If I start typing in RAN for range, I don't get anything. Okay, so what I need to do is actually work it out. So I need to insert a few extra cells to do that. And what I'm doing to get an extra row in, folks, I'm clicking on the row, right-clicking, and then just hitting insert. Okay? So for the range, I can put in the max, the minimum, and then I have the difference. Okay? And the difference is effectively going to be your range. Now, it depends on exactly how you want to display it. So if you wanted to display it as mean, up to the range and down to the range, what you're going to have is upper range, so the difference between the max and your mean, and you're going to have a lower range. Okay? Now we know the terminology is a bit weird, but you kind of have to work around Excel a little bit just to get it to do some of these things. It's quite capable of doing them. It's quite capable of doing them. Yeah, I will show you how to do SEM again, Alice, that's no problem. I'll just come back to it after the range if that's all right. So for max, it is very unsurprisingly max. So again, now that we know it's B3, because that's where our data starts, and it goes as far as B22. And you can see the little blue line has appeared at the top. And that shows me that we have the right range. So there we go, our max is 6.02. And again, for minimum, we can type in min, B3 to B22. And there's our minimum. And the difference is very easy, it's max minus the min. Okay, so if I wanted to display it as mean going up to the highest point, I have to find how long that distance is, how long the range is from the mean. So one way of doing that is to get the difference between our average and our maximum. So equals maximum minus the average. Okay, and we're doing it in that direction because we want a positive number. The lower range is the average minus the minimum. And that gives us from the average to the minimum. Okay? So now we have a bunch of numbers that correspond to our range. I'll just highlight those in green so we can see those as a block. Okay, is that making sense, folks? We'll turn these into charts very soon, and maybe it'll become a bit more obvious then. And just to come back, Alice, just about the standard error of the mean, okay? I'll just make this in notes. The standard error of the mean is equal to standard deviation divided by the square root of n, where n is the number of sample. So what I've done in this case is I've set up a formula which looks at B26 surrounded by blue here, and that's the standard deviation, and I'm dividing that by the square root of the count of my samples. I'm not putting square root 20, I'm putting the square root of the count of my samples. Because that means if a sample disappears, so if I delete 1 or 2 or 3, everything automatically readjusts. Okay? And that's obviously very valuable when you have a large data set. So, confidence interval is actually reasonably straightforward to calculate because there is a formula for it. Okay? So confidence interval for the mean of the population. Okay? And if people are, I suppose, a little bit unsure about what confidence interval actually means, okay? Basically, it means that if you do something, if you have a 95% confidence interval, what it means is that if you do it 100 times, 95 times, if you remeasure it, reproduce it, whatever it, 95 times out of 100, it will be in that range. So you're setting a range of variability, an acceptable variability. Okay? So if we put in confidence, open the bracket, you can see we have a couple of different things that it's looking for. And if we don't know what one of them means, I can hit on the button and it should give me some instructions. Okay, it should give you help when that happens. Okay, and I'm not sure why it's refusing to cooperate. So I'm just going to go into the formula-based one, just so, because it'll show you what the actual help text is. So here we have the significance level. Okay, so if you put in 0.05, right, that's not very good, is it? If you put in your standard deviation, you can pick it from, because we've already calculated it. If you put in your size, we have our population. Okay, and then we get our confidence interval based on that result. So, because we were looking for a 95% confidence interval, we put in an alpha of 0.05. Okay, if you wanted a 99%, you'd put in 0.01. And what you'll notice is the lower I make, or the more, I don't like using this phrase more significant, but the broader I make my confidence interval, i.e. the greater likelihood that I will find my data in this in future should I repeat it, the bigger the number becomes. Okay, so let's change it from, here's a confidence interval, here's a 90% confidence interval. Okay, here's a 95%. So we've gone from 3.5 to 4.2. And again, if we go up to a 99% confidence, we have 0.55. So it's changing all the time. But at the moment, we have a 95% confidence interval. Okay, so the last one that people had highlighted was the CV. And the CV is the standard deviation, which we've calculated, divided by the mean, which we've calculated. And typically, you're going to multiply it by 100 to express it as a percent. I should have put in percent CV. So the symbol for multiplication in Excel is an asterisk. And there we go, we have a percent CV of 20.1%, or 21% nearly, which is not good at all. Okay. So are we happy enough, Alice? Are you managing to keep abreast of things okay, or are you getting bumped out constantly? Okay, so let's just do a little bit of very quick, very dirty, I suppose, and efficient calculations using this little black window. So we've set up our data in such a way that if I drag this little window across, it will automatically calculate all of those things for me in a second. So now I have all of the data for all of the different sets of data, or all of the calculations for the different sets of data. I want to get rid of my decimal places, maybe leave myself with 2, that's manageable. So again, I'm just highlighting all the data and okay, no worries, Alice, if you can actually follow, that's great, and if not, you should be able to log in later. So here we have all of our calculations done. So let's now try and actually put these into a pleasing, and note that, a pleasing graphical format. Okay, we don't want just a big dump of information. So one of the things that people will often want to do is to have the average of each of these displayed. You'll notice what I'm doing is I'm actually picking the title for the molecule, so or the analyte, glucose, and then I'm managing to pick the average for glucose. I'm picking triglycerides, and then picking the average for triglycerides. And the way I'm doing this is by holding down the control key and making my selection. And I've picked the wrong ones here. You can see that I've picked the wrong ones. Don't pick the wrong ones, okay? So here we go. And I think, Martina, you were asking about putting 3 things on the one chart. So here's an example of how to do that. So I'm going to insert, and we'll start off with a very standard column. And there you go. Okay? You'll notice that this is not pretty at all. It doesn't look like anything you'd see in a public. Well, okay, some people will publish stuff like this, but they shouldn't. It's terrible. Okay, I don't have a nice number of decimal places. There's too many numbers on the left-hand side of this. Can anybody else spot any other mistakes or defects in the chart? What's wrong with it? Tell me what's wrong with it. And we go through fixing them. Yep, absolutely no units. No axis labels, Jennifer. No title. Now, the title actually is a bit of a strange one. Typically in a chart for a publication, there will be no title on the actual chart itself. Okay? It will be called Figure 1 maybe, or Figure 1A, and it might just have a big A somewhere on it. and the title then is put underneath it in the figure legend. Okay, but yeah, we've spotted a few very obvious things. So how do we feel about the grid lines on this? Does everybody like the grid lines? Are they helping us understand it in any way? Okay. Personally, I don't like them because I think that they can make you overanalyze what you have in a chart. Okay, it can be useful for small differences certainly, but the temptation is to overanalyze what you've got. But let's correct some of the defects that we had. Now, if I highlight this chart, first thing we're going to do is get rid of this Series 1 label because it's not really useful. And then I'm going to adjust it so that it's roughly square. And then we can start working on the problems. So when you highlight a chart in Excel, you'll get the Chart Tools window or tab. And that gives you a couple of options. So we want axis titles. We want a title below the axis for the primary horizontal axis. And we want a title, a rotated title for the vertical one. So there's two titles we've got. To change those, we just have to double click on them or even single click onto them and put in our title for the axis. So it's concentration, it's millimoles per liter, and we have an N equals, well, we can't really say it's the same N for all of them because we have a 20, a 19, and an 18. So for this purpose, we'll just put in the concentration. If you want to put them on a separate line like I've done there, the trick is to hold down Shift and press Return. And that gives you a new line. The axis title for the x-axis, the category is Analyte. So now we have Analyte, we have concentration. They're not really the right size, but that's okay. We're going to fix that shortly. So one of the things that Excel is quite good at doing is spotting how many significant figures you have. So remember, we set up the spreadsheet to have 2. And Excel is clever and says, well, if you have 2, then the chart has to have 2. Okay? So if I draw a chart now based on my data when I've reduced it to 1, I should end up having only 1. But what gives you more control is the ability to change things directly in the axis, and that's this Format Axis option. So where I got that was I selected the axis, and I right-click and go Format Axis. And I have a pile of different options. So I want to change the maximum. Okay, I want the maximum to be 6. I want to change the major unit. I want the major unit to actually be 2. And as I change these, you'll see that they automatically change in the chart. So it allows you to see what things look like, and if you want to change them a bit. Now, I've changed the axis stuff, as in the scale. Now I can change some of the formatting issues. So I don't want any decimal places. So I'm going to get rid of the decimal places and just put in 0. So now you see I have 6, 4, 2, and 0. I can put in 1 if I want to have just 1 decimal place. You can change the line color if you want. Excel has pre-computed versions that it likes. Whether or not you want to use those, that's up to you, but simple is always best. So I'm just going to pick black, and I'm going to change the line style. Excel makes it too thin by default. It makes it 0.75. You probably want 1.5. Okay, and you can see straight away on the right-hand side, as I change this, the thickness of the line increases. So 1.5 is plenty. And the reason you want to make it a bit thicker is that when this is printed, if the lines are too thin, they'll almost disappear. All right? So far we've done fairly nicely. It looks okay. And we're going to close that. So now we actually have something that looks a bit better than we started with. Now it's not consistent with the x-axis, so we need to format that as well. Now, the x-axis is a category. And because it's a category, okay, that means it doesn't have a scale. It's just a list of categories. However, we can change our line style to 1.5. We can change the color to black. And now the axes are consistent. So now you have the start of something that looks a bit decent. You don't need blue. In a graph or chart, you don't need to highlight. What do you mean by skipping in and out, Orla and Linda? I don't see any delay on your video feed. Okay. Right, I'll tell you what, I'll stop this sharing and I'll go back to it, and hopefully that'll resolve it. Better? It may be the Blackboard Collaborate window that I have open as well. So yeah, you should be able to see the chart. So you don't want to have things in blue. So we want to format the data series. And the way we do that is with the Format Data Series option, which I hope you can see. Can you see the Format Data Series box? Because it kind of defeats the purpose if you can't. Okay, right, give me a sec. Okay, how about now I have changed the way that I'm sharing the screen with you. That better? Okay, so you can probably see the chat window as well. And that'll come and go, but right. Let's work with this one. So I am selecting my data, right-clicking on Format Data Series. And what I want to do is I want to change the width of the gap. I want to make my data have big chunky columns, okay? And you can basically scroll this whatever way you like. Don't have them too close. Somewhere around a sort of 30 to 50% generally works. I don't want this horrible blue color. I want to have a solid fill, and I want to pick the color. Now I'm going to pick a dark gray for a reason that I'll show you in a second, but you can just as easily pick a lighter color. At the moment there is no border on these, but we can have a solid black line. And again, we want to change the border style to increase its thickness so that it looks consistent with the graph. Okay? So now we should have something that looks a little bit more close, I suppose, to something you might see. in a journal. Now the problem here that I have is that immediately the text is too small. So I need to increase the text size. And I can do that just by picking the size I want. So I'm selecting the entire graph, and then I pick the text size that I want. So I'm going to say 12. And now you see everything becomes 12. And when the text of the labels becomes big, Excel automatically makes them have this diagonal format, which you'll often see in journals and many people quite like the look of. Typically, your labels should be sort of 1 unit bigger than the rest of the text. So I have font size 14 for these and 12 for the Axis labels. All right. Now what we haven't done is put any error bars in yet. So do people know how to put in error bars? Okay. So the first time I tried to put in error bars in Excel 2007, it took me about half an hour because they were buried away somewhere that I couldn't find them. So where they are is if you click the chart, in Chart Tools, you get something called Layout. And everything that I've done now, the modifications I've done, you can do all of these using these Chart Tools options and functions. But the last one over on the far right is called Error Bars. We don't want any of the built-in ones, okay? What we want is more error bars, because we want to specify exactly what we want. Now, I'm going to have to move this over the chart a little bit just so you can see what I'm doing. But we want to take the standard deviation. We want to go above and below, and that's why I made it a gray. So if we draw our error bars in black, we'll be able to see them. And we want a custom one. So you can certainly pick these and explore them just to see what happens. Okay? But what I'm going to do is I'm going to specify exactly what I want. And again, doing this ties it in with the rest of your data series. So if you increase the number of samples, if you have to make corrections, it'll automatically fix itself. So I would specify what I want, which is the standard deviation, and I'm going to drag it across all 3 of my analytes. So that's my positive error value. Because it's standard deviation above and below the mean, or about the mean, it's the same above and below. So I've picked my error bars and I hit OK. I get some options for line color. I can pick a solid line. I can make it black. And I can make sure that the line is thick enough. And then I hit close. And now you'll see I have a bunch of error bars. And what can you spot immediately about the triglycerides? Absolutely, it's off the scale. So we need to go back to our axis. If we left it automatic, you'll see Excel redraws it straight away automatically. Now, I'm a bit of a control freak when it comes to graphs, so I want to have the control to make it exactly the way I want. So I may end up doing exactly what Excel does, or I may end up doing something different. So I want 7.5 as the maximum, and I want the major unit as 2.5. Because we want to have 5 in here. So now you can see your 3 analytes in a fairly professional looking graph. We still have this black border. We are now going to get rid of the black border by formatting the chart area. And it's border color, and I'm saying no line. Now the reason I'm doing that is now I have this graph that I can literally copy and paste into something like PowerPoint. And what I would recommend you do, as the PowerPoint wakes up, there we go. is, as you're starting to collect data for a project, store them as a PowerPoint file. Okay? Use the Notes pane to basically describe what's in the figure. And you can describe all of the details about it, because you may end up having lots and lots of figures, and by the time you actually get to trying to analyze them and summarize them, you'll have forgotten all of the details. Now I can paste in my Excel, and you'll see it's done this horrible thing. It's changed all of the formatting I worked so hard on. So why would you bother doing this, you're asking me? Well, what you do is you paste it in, but you paste it as paste special. And that allows you to paste it in as a picture. So I'm going to paste it in as a device-independent bitmap. What that means is that it looks the same as it did when we were in Excel. And now I can start to add in some of the extra stuff if I want to. So you can see it's a pretty good picture. Taken directly from Excel. Okay? Within PowerPoint, I can do things like I can add in a symbol for significance or something like that. So let's just put in an asterisk, and I can arrange that in a fairly detailed way to show that this one is significantly different or whatever. Or I can stick an arrow in if I want to highlight something. But that's more of a general tip, I suppose. So that's the kind of way to approach doing a chart. But let's just say that let's put in a bunch of other random data, okay? And say that you want to draw something that looks the same, okay? So you want something that has the same formatting. You've worked on all this formatting for a while and it looks nice and you're happy with it. But now you want to draw another graph which has the same formatting but is not, you're not putting it on the same, you don't want it on the same chart, is what I'm trying to say. It's just a sneaky way to do it. If I select the entire chart and copy it, okay? So I can copy a chart. And then I select a cell next to it and I can paste it. Now I have a clone of that chart. But what I want to do is restrict, I want to change the data. Okay? For this chart, I want to select different data. So you can see I've got glucose, triglycerides, and cholesterol. So I can basically remove those and I can add new data. So I pick my notes and I pick my average. Hit OK. Okay, it's doing silly stuff. Basically, what you can do, sorry, I hit the help button by mistake. What you can do is select the data that you want. So I'm going to add a series. So notes and average. So I'm editing. I want the axis label for notes. I'm going to edit the series that I've got. It's just going to be one. And you see it has the same text, all the rest of it, but because it's only one set of data, it's obviously much chunkier than the rest. So you have a bit of work to kind of make it look, consistent with the others. But it's just it's a much faster way of getting a few charts out quickly. You can, if you want, actually save one of these charts as a template. So you can save it as your own charts template. So now when I go to draw a new chart, so let's take glucose and notes. I want average and average. I can hit insert, column, and where are we? I'll need all chart types. And then you see there's one for templates. So here's MSc Tempalta, which is meant to be template 1. And I hit that and I get my MSc template. So it's got the same colors, the same thicknesses of lines, and so on. They stay up for the whole year, Alice. Whenever they fix the converting them into MP4s, then I'll save them as videos and stuff like that. So one last quick thing, again, I suppose we'll probably have to do a few more of these just to kind of go through some of the other data display options, because we haven't even touched on doing the maximum and minimum. Obviously, you would do it just using for the error bars, you'd pick the upper range for the error bar going above and the lower range for the error bar going below. But just let me try something now. You should be able to do. If I insert. So this is basically the range and the average. Okay, so you need to have it with the highest, the lowest, and the closing. So you could take the closing as the average, and then the highest and lowest. So we would have average, and then the other two, and that would give you the average in the middle going above and below for the range. Again, there are other options to do that. You can use a scatter plot to do it. It depends. These error bars, Orla, are one standard deviation. In a box and whisker plot, it really depends on what you want to display. Do you want to have the median and then the quartiles? Do you want to show the maximum and the minimum? There's a wide variety of different ways of constructing them. It all depends on what you want. Joanne, it depends how you want to present it and what comparisons you're doing. So, for example, I'm just showing you the average values of these, plus the standard deviations. However, it might be interesting for me to do a correlation analysis or a scatter plot. So here I'm selecting my data, and I have a scatter plot of my data. That might be something that I want to display. But it all depends on what I want to actually show and what question that I'm addressing. So I'm just going to pull these around randomly. So here you can see that I've put a scatter plot together, and this is very crude and very quick. This is comparing glucose and cholesterol. And I'm now comparing cholesterol and triglycerides. Say that again, or what exactly do you mean by comparing? Do you mean in the bar chart, Donna, or do you mean in the scatter plot? Short answer, no. You don't need colors to distinguish them because you've got a label distinguishing them. If you were using a different type of bar chart, okay, So if you were going to use, I mean, this is clustered. We don't have clustered, but if we did have clustered information, then yes, you would need to use something. I'll just try and make one for you now. So there you go. So if you're doing something like this, where you have patient 1 and patient 2, and 2 different analytes, in that case, yeah, you may want to have a different color. Is that what you're thinking of? But it all depends on what you're actually trying to achieve with the data display. What I'm going to suggest, guys, is that, like, we've hit time now. I think we'll probably have to schedule an extra one just to deal with sort of the scatter plots and some of the other bits that we haven't got to on this one. But this is really just a starting point, just to get everybody kind of familiar with Excel again and familiar with thinking about how you can put things together. One of the assignments is based on data display, and you'll be getting a big pile of data, something like this, with lots and lots of it, and a set of criteria for how you analyze the data and how you display it. So I'm going to close with that. I'm going to kill the screen now. So what I would like everyone to think about is the types of data that they encounter and how do they know how to draw it? And if you don't know how to draw it, let me know. I probably won't be able to touch base with you tomorrow. This is Excel 2007, Aisling, yes. 2007 onwards all basically operate with this tabbed system. If you're still using Excel 2003, you can do pretty much everything. The formulas are all the same. All of the functions to change formats and stuff like that all work, but they're just, you access them in a slightly different way. But everything works absolutely fine. The dates are from, yeah, the dates, let's say we'll call them flexible because we had a couple of teething problems at the start of getting all of this running, but you will be having a session on it before we started. Yeah, that has been the plan, and actually last year we ended up having 2 sessions on ethics.